Okay, here we are again. Build progress. Today I've populated the rest of the board and I had all of the components, which is a good sign. It's never nice finding out that you've missed ordering some components, so it's very nice that I've got all of them. So a few little tweaks here and there, mostly to the header over here. So this time I'm going to be looking to check the signals coming from the video output header. This should, in theory, comprise of H-Sync, V-Sync, TV Sync, TV Sync out, ground, and analog RGB. Now the logic analyzer will only really detect the signals from about 1.45 volts upwards as logic 1, so I'm not expecting that much data on the RGB channels, but I am expecting valid H-Sync and V-Sync and TV Sync to be observed on the header. So I've connected it all up here, so you can see that I've got my ground wire, the black sleeve there with the grey wire, that's the ground wire, which is connected to pin 1, 2, 3, 4, 5. Pin 5 is the top left of the header, which I believe was the ground on the schematic. So let's just double check that, and if I click over here, and then if the camera wants to focus, which hopefully it will, then if I check here, then yes, the top left is ground. So I've actually all checked and triple checked all of the wiring already because I don't want anything to go pop. I have also, come on focus, I have also set up one of the logic analyzer clock inputs to be the output from the video 1 header of VidClock. This is the 12 megahertz approximately, 6 megahertz approximately clock that is calculated internally. 6 or 12? 12 megahertz. It gets divided by 2. 12 megahertz approximately clock, which hopefully will be used for sampling input by the logic analyzer software. So this time I'm not going to be using the internal clock of the logic analyzer. What I'm going to be doing is that I've set it up here, logic analyzer, to actually start measuring samples on a positive edge of the clock, which is what this little configuration window here does. So state mode, external sample clock, rising edge of clock 1, which is hopefully the vid clock, which is that nice 12-ish megahertz one. Now I've also set up frequency measurement here on D0, can't see that very well, D0, D1, D2 and D3. These should be H-Sync and V-Sync and TV Sync and TV Sync out respectively. Don't forget that TV Sync out went through that those two resistors. Although the logic analyzer should pretty much pick them up as well. So we'll see what we get. I haven't tried this yet. Just double check, triple check, quadruple check all of my connections. The jumper wire here, obviously for enabling the clock crystal based circuit, and is still armed, still closed, and the display enable is obviously being pulled low by the ground input from the not connected oscillator, because I'm using the clock crystal rather than the oscillator package. Because, generally speaking, I just couldn't find an oscillator which was of the correct frequency. I could find one at 12 megahertz, I could find one at 12.1, but exactly the correct frequency that the crystal was, it just wasn't findable on Mercer, so I opted for the clock crystal. So I'm going to turn everything on. I'm then going to see what the logic analyzer picks up. Fingers crossed, huh? So I'm going to quickly ground myself, and then I'm going to turn on. Oh good, there's a good sign the light has come on. And the first bit of good news that I can see here is that D1, which should be in VSync, is a nice steady 60 Hertz, which is fantastic. And also the H-Sync is also a nice steady 15,750 Hertz, right? 15.75 kilohertz. Now, if I remember my specifications for NTSC, that works out around about the right values. Definitely the right value, 60 Hertz, rock steady 60 Hertz, which is fantastic to see. And now this D2 frequency is interesting, and the D3 frequency is also interesting. So what we're seeing here is that we're seeing the frequency from the TV sync. Now, TV sync is basically a combination of H sync and V sync. And of course, if it's in the V sync, then I would be expecting quite a long low signal to be held, and then all of the subsequent H syncs should be quite short. So I think the frequency measurement here is going to be oscillating around, because it's basically measuring the frequency from a non-stable logic source, which is probably what's happening right now. So what we'll do now is that I will set up a quick capture, and we'll see what we get from the actual board itself. Okay, let me just zoom. There we go. That's absolutely perfect. So if I zoom in a little bit, and I'll zoom in a little bit more, and a little bit more, it should become very apparent what this is. So I will use the mouse. So this low signal here, and then going high. So the low signal is quite a short blip, low, and then most of it is high, followed by lots and lots of spike. So, well, lots and lots of low signals. So what are we seeing? So if I look at the already set up values here, I'm looking at, I had a trigger on the positive edge of VSync. So actually what we're seeing here is that we're seeing the trigger 0 time up here. We are seeing the exit of the VSync, and we can see the entrance to the VSync here. This is before the trigger, and this is after the trigger. So the great thing about this logic analyzer is that it will fill the buffer, and then it will send you what had happened and then what was happening during its recording. So that's, it really gives you a good context in terms of history. So what do we see here? We see the VSync ending, doink. We also see, if I zoom in a little bit more, we can see the VSync ending and then H-sync starting, doink, H-sync finishing. Now what we are seeing here also is, this is fantastic too, is that because the input pixels are just floating around, and because we are using whatever data just happens to be in the palette RAMs, what we are seeing here is that we're seeing a little blip of color just after the H-sync finishes, and then we're seeing not much at all, another blip of color, blah 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 blah. This is rather intriguing. I wonder why we're seeing color at the beginning of every scan. This could represent all sorts of things. It could represent color from a particular part of the palette being picked at this particular time at the beginning of the scan. If we zoom in a little bit more, we can actually see the fine timing for this. So that's going to be interesting to see what's happening there. So what we do see is that we see some very clear intended timings for NTSC, and we see some H-sync, V-sync. So what I'm going to do now is that this seems to be working. What I need to do now is that I need to transfer this working board over to the retro gaming input video signal decoder, which will then decode to a nice VGA signal, which then I can display on a normal LCD screen. Because, as I say, I don't have a display really capable of absorbing these kind of inputs anymore. I used to have an old, very nice, large screen Sony, which had all sorts of nice video input conversion, but I don't have that, unfortunately, anymore. So I'm going to have to make do with the retro game video standards conversion board instead. One of these magic little boards from China, which does its job. So that's going to be the next step. So here we are, I'm back at the workbench, and I have connected up the TV sync wire to this magic video decoding board. As you can see, it kind of does CGA, EGA, YUV, 2VGA. It's got all sorts of lovely, wonderful inputs. The one that I'm currently using is this one. RGB sync, H-sync, V-sync, ground. So the ground wire is connected to the header that provides the ground, so it can find a common ground. That's kind of very important for measuring the signal against, because we're dealing with analog electronics now. And the sync wire, this grey one, is connected to how does it go to the header? H-sync, V-sync, TV sync, and TV sync out. So in theory, the TV sync should be the sync signal it's looking for here. So I'm going to tilt up to the screen, and we'll see if any magic happens. So first of all, I'm going to turn on the video decoding board. Okay, there we go. Chinese characters, then no signal. No signal is expected because the board is all switched off. I'm now going to supply power to this one here. Oh, no, it's already on. I've just got to switch the switch on. Green light. Oh, great. And the screen has got rid of the no signal, and it's now displaying analog. And it says that it's doing an auto brightness adjust thing. Now, I have not connected up the RGB signals at all. So what I'm going to do is I'm going to take the red signal, this one here, that wasn't connected to the header. Don't forget that we just connected up the TV sync and the ground. So I'm going to connect up the header here. I'm going to see what we get on the screen. Oh, okay. So this indicates that whatever the video decoder is doing, it's decoding something. It's found a stable-ish video signal, and the wire that I'm currently wiggling around in the... Oh, it's just gone no signal. That's probably because I'm wiggling it around too much. So if I put that back in again, there we go. So the video decoding board has picked up some kind of signal. I don't know what. Random red wire going onto one of the terminals down here produces weird patterns. So I guess this means that this video decoding board is picking up the same signals that I saw on the logic analyzer. So I'm not expecting any picture to be observed, of course, because the state of the palette RAM could all be blank. The state of the input pixels are floating around, so it could be outputting anything, to be honest. So now what I need to do is that I need to start connecting up the header here to the proper kind of like memory input. So what I can do then is that I can start filling the palette RAM and then faking some input pixels here, and hopefully I should see a nice stable input on the screen. That's going to be the next thing to do, I think. What should I do? Well, maybe what I can do is that instead of using this board, which to be honest does not generate a very good video signal, what I could try doing is that I could try using the other decoding board and see if that picks up any of the better timing debug information, because I kind of forgot. It's ages since I've used this board, and this board doesn't seem to throw up any debugging information about video signal standards. So that's what I might do. I might try the big board, which gives LCD debug display information about the video signal it's getting. So I think I'll try that. So this is a different retro video conversion board. It's actually a lot more modern than the previous board. This is the one with the LCD debug display. So what I've done is that I've switched on this one already, and there's no signal on the monitor. It outputs HDMI rather than VGA this time. But what I've got is that I've got VGA cable coming into AV3. And at the moment, the card is off. But what I've done is that I've used the video header, but this time the ground is connected to the ground of this VGA header here. So this VGA header goes into this breadboard, and this breadboard goes red, green, blue, coming towards me. But then this here is ground, the third one, this one here. And then the next one along is H-Sync or Color Sync, and then this is meant to be V-Sync. And originally this board was made for one of my Commodore 65s, where I was debugging Commodore 65's RGB H-Sync V-Sync output. And I found, weirdly enough, that I could connect the Commodore 65 through this connector here to get it RGB and H-Sync and V-Sync, and then I could pipe it through a VGA connector, believe it or not, to one of my old monitors that would accept a 50 Hertz VGA style signal. It was an old Sony, I think it was a fantastic monitor, but eventually, it blew up. Not, quite literally, but the magic smoke escaped. Anyway, so what I could find out was that RGB H-Sync V-Sync actually worked pretty well on that monitor. So that's what I used to use for this. But I kept the old breadboard around because I thought it might be useful one day, and it's useful for this one now. But instead of connecting V-Sync, because I don't think V-Sync will work terribly well with this AV3 mode, so I think I'm going to try it just with the color sync information first. So the color sync information goes to what is basically after H-Sync and V-Sync, the next pin up is TV Sync. So I'm going to connect all that together. I'm going to turn it on, and I'm going to see what we get. Now, I'm not expecting anything to be visible on the monitor, but what I am expecting is that this to show that it's locking onto a signal. So I'm going to switch it on here, and then 3, 2, 1, fingers crossed. Ooh, fantastic. So immediately it's telling me that RGBS with the separate sync signal is 261p, which is about correct. It's at 15.74 kilohertz and 60.31 hertz, which is, again, pretty darn good. I love this one because it actually gives you some really useful debugging information about what it is currently seeing on the inputs. Just to be on the safe side, what I can do is that I can press this button here and it will go through and RGB sync, RG sync B, I think it's sync on green, no sync signal, AV3, Y, PPPR, no, obviously not, I'm not outputting that kind of thing. AV1 obviously no, AV1 no, AV1 again no, AV2. AV2 comes into this SCART connector here. The Commodore 65, one of the other ones, was piped through a SCART connector. It worked really quite well through this. There's no HV on this, but this one has locked onto the signal again. So that's nice. So what I'm going to do now is that I'm going to, again, take out the red wire. And because the red wire is connected, I'm just going to futz around. Futz, F-U-T-Z, it's a technical term. I'm going to futz around and I'm going to see what happens. So that's definitely red signal, red signal. I'm just poking onto random pins here on some of the chips just to see what it does. So I'm definitely getting some kind of red signal. I think it's probably saturating. Ooh, look. This one is some kind of timing signal, and look at that. That is actually pretty darn steady. That is this pin here on this chip. I'm going to find out what that is later on. Not right now. I'm tired. Oh, look. I've got a nice full red screen now. Wow. Okay, nice rock steady picture. That one's nothing. That one's kind of something, but not much. Just poking around on random chips to see what signals you can get is one way of learning what your electronics does. This one has some really interesting lines on the screen. This one just gives me a solid red. Okay, cool. So I think that's a winner. I think it means that, something is generating some kind of roughly sensible video signal that two, video conversion boxes can actually lock onto. I'm going to stick with this box. This box seems to generate a much better video output over HDMI for the video, for the monitor, for the screen. So I'm going to stick with this one. What I'm going to do now is that I am going to header up the rest of these headers here. Okay, and then after that, what I should be able to do is that I should be able to create something on this breadboard here, or maybe another breadboard, which will basically start filling memory. I will be able to program the palette RAMs here. So actually these two 114s, when this is running, actually get quite warm. That's a good sign. It's actually showing me that the board is working and it's sucking information from these palette RAMs here. So they get a bit warm. Not too warm to touch, but they definitely get noticeably warm. Some of these other chips here, they also get quite warm. This is not a surprise because this board is running at 6 megahertz. So anyway, what I'm going to do now, as I said, I'm going to header up the rest of this board. I'm then going to create some breadboard here to create a debug memory interface. I'm going to start programming these palette RAMs here with some meaningful information, and then I'm going to assert different pixels here. This one, and this one will be blank, I expect, and then this one will be the first one that I take. Or maybe this one, and this one will be blank, and then this one will be the pixels that I want to output, just to basically test the one plane logic and see if I get something on the screen. I might attach a counter to here, for example, or I might just have a solid pixel color asserted on here or here, and then see how that goes. Okay, great, fantastic news.